Have you ever wondered how a machine could learn to master something with, no instruction manual, no map, nobody telling it what to do? Well, today we're going to dive into Q-learning. It's this beautifully simple idea from way back in 1992 that totally changed the game by letting machines learn from pure trial and error. And it really all boils down to one simple question.
Right? This is the core problem. Think about a character in a video game just dropped into a brand new world. How in the world does it figure out how to win when it doesn't even know the rules? Well, this is exactly the kind of puzzle Q-learning was built to solve.
To really get our heads around this, we're going to use a simple little analogy. We're going to follow this robot, our agent, as it explores its world. And along the way, it's going to build what we'll call its secret ultimate cheat sheet for success.
Okay, first up, let's meet our hero. We're calling it a robot with amnesia. Why? Because it has a goal, sure, but it's starting out with a massive handicap. It knows absolutely nothing.
So here's our agent. Its whole world is this little maze, and its one and only mission is to find that reward at the end. The catch? It is completely, totally clueless. It has no idea about the layout, where the traps are, or where the prize is. It's literally starting from scratch. Zero knowledge.
The only way our agent learns is through a super simple feedback system. It gets a bunch of positive points when it finds the goal, the cheese, and it gets negative points when it hits a trap. That's it. These rewards and penalties are the only clues it has to figure things out.
So you might be asking, how does a robot with amnesia actually remember what it's learned? Well, it builds itself the ultimate cheat sheet. In the world of machine learning, they call this a Q table.
Now this is the absolute key to the whole thing. Every single score on that cheat sheet is what's called a Q value. You can just think of it as a prediction. It answers the question, okay, if I'm standing right here on this spot, what's the potential future reward if I move up or down or left or right? A high score means it's a great move. A low score? Not so much.
And here's what that cheat sheet looks like at the very beginning. It's totally blank. Every possible move from every single location is just a big fat zero. This represents total ignorance, right? The robot has no reason to think moving up is any better or worse than moving down, because it just hasn't experienced anything yet.
So how does the robot start filling in all those zeros? This is where the magic really starts. It learns by doing. It just starts exploring its world, one step at a time, to figure things out.
The learning process is this really simple, elegant loop. First, the agent just tries something, usually totally random at the beginning. Then it sees what happens. Does it get a reward or a penalty? Then, and this is the most important part, it updates the score for that specific action on its cheat sheet. And then it just does that over and over and over again. All right, let's watch its first move. From square B2, the robot decides to move up. And zap! Bad choice. It gets an electric shock, a penalty of minus 100 points. Ouch. But you know what? This failure is incredibly useful.
And here's the update. See that? The robot goes back to its cheat sheet. The score for move up from location B2 isn't 0 anymore. It's now a negative number. It has learned its very first lesson. Moving up from B2 is a bad idea.
Okay, let's fast forward a bit. After wandering around some more, our robot finds itself at location B1. This time, it tries moving right and jackpot. It finds the cheese and gets that massive plus 100-point reward.
And what does it do next? You guessed it. It immediately updates that cheat sheet again. The score for moving right from B1 is now a huge positive number. The robot now knows that this specific action from this specific place leads directly to the best possible outcome. So what happens after thousands or even millions of these little trial and error attempts? Well, the robot isn't just learning about the obvious traps and rewards anymore. It's actually learning the value of every single step along the way. After a ton of practice, this is what the cheat sheet looks like. It's complete. Notice how almost none of the values are 0 now. The scores don't just show the immediate reward. They actually reflect the long-term potential of every single move. See, a move gets a high score if it leads to another square that also has a path to a high score. It's brilliant.
And just like that, the learning part is over. The robot is done exploring randomly. Now, from any square in the entire maze, it just has to look at its cheat sheet and pick the move with the highest Q value. It now has a perfect strategy to get to the cheese from absolutely anywhere on the board.
And here's what made Q-learning such a revolution.
The original paper from 1992 actually proved, mathematically, that this simple process is guaranteed to find the absolute best strategy. The probability of it working is 1. It wasn't just a neat trick, it was a rock-solid method that researchers could rely on.
So this simple idea, a robot in a maze, it ended up becoming one of the most fundamental building blocks for all of modern artificial intelligence.
You know, the core logic behind Q-learning, this whole idea of learning values through trial and error, it is foundational to so much of the AI we see today. We're talking everything from AI that can beat the world's best players at super complex games, to robots that teach themselves how to walk, and even the algorithms that optimize stock trades or recommend what movie you should watch next.
What's amazing is that even its creators knew how big this was. They called it a primitive form of learning, but they saw that it was the seed for something much, much bigger. You could say this little cheat sheet concept is basically the great-great-grandparent of some of today's most powerful AI systems.
And that kind of leaves us with one final thought. This whole incredible journey started with a robot that knew absolutely nothing. It learned everything it knows just by trying things and failing. If a principle that simple can achieve so much, it really makes you wonder, what's the next big leap going to look like?